So we're waiting one more minute then? And then, oh, wait, it's 12:05 already by my clock. So shall we get started then?
I say let's go.
Okay, so the first thing I'm going to do is change my video background to something that won't drive you nuts, right? Because that I'm gonna be nice about it.
Thank you.
Few things here, guys. I've been meaning to do something like this for a while, but there's a reason why I kept it, super, very specifically for a conference like this. Because the stuff that we talk about here is not something that you use every day, right? I don't expect you guys to use any of the concepts that I'm trying to show you or talk about here today. Because really this is more about the stack itself, right? It's more about, how SQL Server does I/O throughout, right? From the very application that SQL Server is, all the way down until what happens at the storage device level, right? And that's something that, it's a good knowledge to have, the skill sets and the things that you're required to have under your tool belt in order to do that troubleshooting of that stack efficiently on a daily basis, it takes a long time to kind of become comfortable with and kind of master. So from that point of view, I really want to do, a few demos, a lot of talking, a lot of getting you in the right mindset of thinking about things, because this is good knowledge to have, right? One of the biggest issues that I see out there as I work with my customers is that we don't know enough about how SQL Server does I/O. We don't know enough about, what happens when SQL does something, and the impact that the operations at the higher level in SQL Server can have on storage and storage in general. And, so overall, I feel that it's a very good discussion to have as a community. So I wanted to do a session, basically expanding on a session that I did earlier on this year that I keep delivering at SQL Saturdays and throughout, COVID, and I probably will continue to deliver that presentation throughout. Let's say that session in particular was called SQL Server Virtualization and I/O Patterns. And that session was recorded for Group By, right? The other community brand conference. And that's the link, okay? So if you're not a storage person at all, you don't know how SQL Server storage works at all, it's probably a good idea for you to go watch that first before we have this more in-depth conversation. And I'm totally fine if you guys just, hang out without paying more attention, or just drop and go watch that, and then we can have a chat on Twitter later about what you learned, and then you can come watch the recording for this. But I want you to really guys understand that this is a higher level conversation. I'm not gonna go into details of what latency means and things like that. That is something that we discussed in that talk, and you should go watch it if you don't even understand what latency means, right? Because it's a super important conversation to have. So I also left in there a blog post that I think reinforces what that talk discusses, right? What that video discusses, and then you can take it from there. You can come back and watch this presentation, because it'll actually get you thinking a little bit more about all the different moving parts and things like that. So with that said, about me, I am a vendor and I work in sales, and that's okay, right? Vendors can be technical, vendors can be community participants, and if you hate vendors, I'm sorry that you had a bad experience with vendors. I try not to be that vendor. But I'm also an architect, but please somebody remind me what architects do, because I don't know. Also a former data platform MVP, aka SQL Server MVP. I am a former vExpert. I am a former principal PM at the Tiger team at Microsoft and the SQL Server engineering team. I guess I'm a former MCM. So I'm a former a lot of things, but more importantly, I'm an ally. And I'm an ally for those who are underrepresented. So if you are one of those, I am happy to be your amplifier of your message. So please reach out to me. I am wearing black on purpose today. So the agenda, very important agenda, right? So what are we going to talk about here today? Tracing. Yeah, we're going to talk about tracing. Maybe we'll talk about tracing. How about we talk about tracing? But seriously, we're going to talk about how you trace things at the application level, right? And more specifically here, we're going to focus on SQL Server because that's what we do. We're going to trace things at the guest operating system level. Okay, that's also very important. Pretty much everyone runs your SQL Server on top of a hypervisor. So we're definitely going to look at the guest OS aspect of things. We will definitely chime in with how things work on bare metal, how things work on containers. Maybe we'll throw in a couple of things in there, here and there. We'll see. Hypervisor. So how do we trace things at the hypervisor level? So start thinking about the stack, right? There's an application that runs on top of a guest OS, that runs on top of a hypervisor. And there's maybe a storage network, right? If you're using a device like the ones that my employer sells, there's definitely a storage network, right? Because there's some communication between you and your storage array. But that's optional, right? If you're using DAS, like direct attached storage, you don't necessarily have a storage network. You have a bus though, and that bus on itself can be a problem. And then finally, there's the storage device. So once you get to that, storage device at the very end, what happens, right? Like, what's the deal with that storage device? Do they all work the same? You know, how do I even troubleshoot something when I don't even know how it works? I guess that's the larger question that we have to ask ourselves here. Anyway, I don't expect you guys to actually read this, but this is just a reminder. This comes from from that presentation that I linked earlier to, the group by presentation. This is the stack, the storage stack within Windows as it was a few years ago. It hasn't changed very much. It may actually be a lot more complex. I don't expect you guys to go like squint at every single box and say, what the heck is that? No. I want you guys to really consider what happens even within a guest VM. All the crap that you have to go through just to place an IO. And I'm calling it crap. We know everything has a good function, right? Everything is in there for a reason. But guys, this is super complex, right? This sort of thing make people go like, really? Just to place an IO, I have to go through all these things? But you know what? Operating systems and applications like SQL Server are super fine-tuned to make sure that if you do have to issue a latency-sensitive IO, you can effectively place that IO and minimize the amount of interactions that you have for the entire stack all the way down. And that's very important to understand, because even though you can have a system with a lot of moving parts, you can indeed achieve great performance regardless of how many layers you have. And that's a conversation that's always resonating with people as you discuss VMs, because people have this thing in their head that a VM cannot possibly have great performance. That is incorrect. A VM can always have great performance if you're doing the right things. So this is just, you know, a generic conversation about performance and IO for applications. But I want you to understand, all of these things could be a problem. Like literally every single thing in here could be a problem. So can you even begin to understand all the things that you would have to master in order to troubleshoot absolutely everything in here? I don't think there is any one person in the world, maybe there's a few people, you know, at Microsoft that actually understand every single moving piece in here. Oh, by the way, there is something that is always wrong in here, that if you do it, you will get bad performance. That's an antivirus. If you run an antivirus, an anti-malware software, and you actually scan, let it crack open IO against your database files, you will incur into latency. No question about that. So I also mentioned that in that previous talk that I had, but I want to reiterate it here because that's something that I hear a heck of a lot. Oh, I am installing this fancy, you know, anti-malware that some geniuses in Eastern Europe created. Great, that's awesome. Are you skipping your database files though? Because exactly what they do is inject themselves here in the file system driver on tfs.sys, and they crack open every single IO that you issue against SQL Server. And then you find yourself in a situation where every IO has free latency added to it. Yep, that's a problem, isn't it? Anyway, let's keep talking about things because I can hang up. I get hung up on this, and I rant a lot about this slide. But that's because, you know, I see too many boxes and I start thinking, why is this so complex? Anyway, let's talk about tracing in the application or in SQL Server. So I want you guys to think about how SQL Server does I/O, right? There is a level 500 talk from Bob Ward from PASS, what is it, 2014, I believe, that is inside SQL Server I/O. There is a YouTube video on that, I believe. If not, it's in your past recordings. Go watch that. It's a great talk. It's a brain melting talk. I think it's even more brain melting than this morning's talk because it's insane, right? It goes over every single aspect of SQL Server and I/O, and things haven't changed much since from a architecture and topology point of view of SQL Server. So that a lot of the concepts are literally exactly the same, even for SQL Server 2019, and even for SQL Server in the cloud, right? So even for Azure SQL Database, and you know, whatever fancy name they give to whatever PaaS service that runs the SQL Server engine underneath the hood. So I want you guys to go watch that if you're really into making your brain go mushy. It's a very good way of achieving that. However, there's a demo there that I'm going to actually sort of kind of repeat because I want to show you guys pretty much the only way that you have of tracing I/O as it goes through Windows end to end, right? Like which pieces of the equation are hurting my I/O. There's literally not a whole left. You can attach a debugger to the kernel, right? So let's start with that. You can attach a debugger to Windows, and even using public symbols, you can start debugging Windows, right? You can start debugging the whole thing. And, you know, and just SQL Server is just one of the applications that run on top of Windows, and you start, you know, digging into every instruction that is called and every single function that is called, blah, blah, blah. That is the only way to really achieve true tracing of an I/O as it's issued from SQL Server all the way before it leaves the actual machine, be it virtual or physical, right? You can do that. Most people don't do that, right? Because it's so complex and there are so many moving parts. And guess what? You're gonna make your system go super slow as you're debugging. So that's just the way it works. So let's look at a few things for capturing I/O within SQL Server. The first thing I'm going to do, so that we get that out of the way, I'm going to crack open the debugger. So here's Windbg Preview, and this is what I was referring to earlier on Twitter when I said that I was going to show preview software for my demos today. This is Windbg Preview, the Microsoft Store version of Windbg. I actually like it better than the regular version of Windbg. That's why I'm using it. So this is kind of how it looks like. It's a little bit more graphical, a little bit more friendly. And, like people love their command lines and their debuggers have to be as dumb as they possibly can get. I like graphical, that's okay. Like I use SSMS a lot, that's okay. And so anyway, let's go ahead and attach, and let me show you the scenario first, sorry. So we go here, this is my SQL Server 2019 instance. Okay, there isn't anything fancy about this. It's just got the latest CU, and thanks to Arvin Microsoft that helped me figure out that I was doing a really stupid thing and I couldn't load my symbols yesterday. I was able to load my symbols, no problem. This is running the latest CU of 2019. I created a tiny a database called TinyDB, and then it created a table called dbr.small. And so this table is nothing, absolutely nothing fancy, okay? It's got an ID and a filler column, and that filler column is, it's the characters 8 KB all in caps. So nothing fancy about it. Let me just actually make sure that we have that table there. We do. Okay, so here's what we're gonna do. I'm gonna insert into that table a default value. Okay, just, it's an identity field, and for that ID, so it will grab a default value, whatever that is. And then I'm gonna, in whatever filler default I specified in there, it'll insert that. Okay, so I wanna see how the I/O goes through SQL Server on its own. Now, when we write even to a tiny table, so let's think about this for a second. When we write to a tiny table, the way that SQL Server does things is, we have to follow the write-ahead login protocol, right? So I'm not going to just write to the data file at once. SQL Server doesn't do that, right? What does write to the data file for us? Checkpoint and lazy writer, right? SQL Server first writes to the transaction log. And when it writes to the transaction log, a very important key proposition of writing to the transaction log is that it pushes the IO all the way through with write through, meaning that IO cannot land on a volatile or non-persistent or ephemeral area of storage. Okay, that's very important because if you land that IO on a volatile area of storage, like a DRAM cache, for example, then it'll blow up, right? The moment that system goes down, whatever data you had in there is lost. When SQL Server tries to recover that database, it may potentially discover transaction log corruption because there were some IOs that were supposed to make it into that particular storage device and never did because it crashed before it was able to read from it. My point is, transaction log writes are especially important in SQL Server, right? All writes are really, but transaction log writes are very, very important. So what we're going to do here is just trace that transaction log write from this particular statement into SQL Server. And so it's important to understand, and I'll refer you to Bob's presentation from PASS a few years ago, that SQL Server actually uses asynchronous I/O. Asynchronous I/O means that it's not going to issue the IO and wait for that IO to come back before it actually moves on and does anything else, right? Your CPUs are way too fast, your memory is way too fast for them to be waiting for your storage device, which is awfully slow in the big scheme of things. So rather than doing that, SQL Server is just going to use one worker thread to place an asynchronous IO request that maybe another worker thread would actually pick up as completed, and it will give you the result from it. Right? So in this case, we're just going to trace it, see what happens. But I'm also going to look at just one thing, transaction log flush, right? So I'm going to look at this particular function here on the SQL Server Log Manager that actually performs the log flush. You know, when we actually create records for the transaction log as part of the write-ahead login protocol. Those records have to be, they're first loaded into a log cache, and then they're eventually flushed down to storage. When they're flushed is when the IO actually takes place against the actual storage device. And at that point, you know, once that happens, we're going to be, SQL Server is going to be placing a call to Windows and saying, oh, hey, by the way, I need to go write to that file using the NT write file API, the Win32 API for write file. So first of all, we'll make sure that we have symbols. So we'll go check out the symbols in the debugger really quick. Where's my debugger? Here we go. Settings. Debugging settings, and my symbol path seems okay, so that's fine. I'll have to double check that again. And now I am going to go attach to a process. And this is where I like the preview version of Windbg because it's pretty cool, right? So I see all my processes and I can sort things and I can just scroll down here and have a lot of crap running in this machine. Please ignore that. There's my SQL Server.exe, right? And if your name is Brent Tosar, you probably want to debug this other guy, SQLCEIP.exe, because that's the one that does the telemetry stuff. Okay, so attach to the SQL Server.exe process, right? And that's how you get your SQL Server loaded or attached to the debugger. So now I just want to make sure then that I list my modules loaded for SQL Server to make sure that everything's good, right? I see that effectively SQL Server has been loaded and I have my symbols working just fine. Right, I am going to go set up my breakpoints. So I'm going to tell the debugger, hey, this is my function that I want you to break at. So I'll go paste that. Right, I want SQL Server to break on that. Right now, I'm not logging anything to a transaction log, so that's great. I can just say go. I'm sorry, not go, G. And then it continues to run, right? But now I want it to break at a different call within that same stack. But we're running, so we now have to trigger that previous breakpoint, right? How do we do that? We go into, and we actually run our statement that will trigger the log flush to happen, right? Hopefully everyone is following me on this. We have hit our breakpoint, right? Because we issued a write that actually incurs into writing transaction log records, and then SQL Server decides that it has to flush them, right? Because it has to every time, right? And now what we're going to do is set another breakpoint within write file, because we are already within the context of, I can show you this, the stack. We're sitting here in this particular stack. And so here's the thing, here are some things to kind of keep an eye on. Somebody started execution of something, a statement, some DML statement. Somebody started some transactions, recovery units. Oh, we have to actually harden the log. Oh, we have to wait until the transaction log is written. Oh, before you do that, you kind of have to log the, call a log flush. Okay, so that's where we're at. Now I'm gonna add the second breakpoint. That's the one on write file. When we call log flush, eventually those that flush from that area of memory that contains transaction log records has to be flushed down to my storage device. So for that, we call write file, right? So we're gonna cause a break on write file as well. When we hit go, we're gonna hit that breakpoint right away, right? Because that call to log flush was eventually going to go write file, and these things happen super fast. So we knew we were going to hit this particular call writing to the transaction log file. So if we look at the kernel stack with K, now you can see, right, that this is a different thread that is doing things. And this guy actually picked up the IO as completed, right? This is just how asynchronous IO on SQL Server happens, right? Somebody called the log writer, hey, that we had a log cache that was flushed. Their synchronous write actually took place, and here's the write file taking place on that, right? Fantastic. This is exactly how it goes. Okay, so here's where we are. We have traced SQL Server's request for an IO all the way down to the NT API, 132 API call for write file. You can indeed dump the memory that refers to the actual transaction log write, meaning you have a log cache that you're forcing to be written down to disk, right? You're issuing an IO for that to be persisted. This is a very interesting thing, because within Windbg and other debuggers, you can actually script things out. And you can do interesting things like saying, you know what, whenever I see a write file, I wanted to see the contents of memory that are going to be written down for that particular write file, right? And I ran out of time preparing for that demo, so apologies for that. But you know what, that's actually a great exercise. If you like this stuff, go play with that. You can create a breakpoint on write file that actually goes and grabs from the memory address that has your buffer data that is going to be written down to your storage device, and then output that. You know who uses that kind of stuff? The malware investigators, or the researchers that are looking for malware. You know why they use that sort of stuff? Because malware typically will go ahead and do like really nasty things, like create other files from scratch that are executables that will trigger something else to happen on your system. So that's one of the techniques that they use for researching executables out there. And some people in our community have actually gone through very lengthy exercises of reviewing instruction by instruction how SQL Server does things. By the way, if you must know, if you look at the registers, of particular interest is the RSP register, right? The ESP register is the one that you care about. The EVP and the ESP registers are the ones that you care about for outputting the information that is about to be written to the file. Anyway, we're just tracing stuff at the SQL Server level. Okay, we could trace things at the operating system level. We could take a step back and just debug the entire OS like this and go call by call. What is SQL Server doing? What is the OS doing? And eventually the OS is going to call a primitive, a function, a routine, however you want to call it, on the actual interface to the storage device to perform that IO. So if you think about a physical host, well, you're going to be doing IO against, maybe you have an HBA because you're connected to a SAN, or maybe you have a PCIe bus and you have some DAS attached to the PCIe bus. Well, you're going to place a request that effectively leaves, the confines of CPU and memory complex into those storage devices. And you can trace that IO all the way down there. So before that IO leaves the confines of what we call the operating system and is issued against that storage device, there is something that's called store port. So with that, I'm going to pause. I'm going to detach here, and we'll go talk about store port. Store port, where is my store port? Oops, what did I do? Did I stop sharing? I think I did. Yes, I did. So give me just a second because I need to get this out of the way. So where's my store port thingy? There we go. Okay, so it's important for you guys to look at this. This is the stack, roughly, very simplified, or what I showed you earlier, okay? So there is, SQL Server sits here, your file system sits here, volume partitions, blah, blah, blah. And then there's the store port sits in here somewhere when you issue SCSI commands against the device. And you're typically, today, you're using one or two things. You're using a SCSI device or you're using an Nvme device. Both go through store port, okay? So in there, it doesn't say Nvme because it's a fairly new technology, but Nvme drives also go through this, or Nvme devices go through this as well. So we're basically tracing at the lowest level possible before the IO leaves Windows, the operating system, and is issued against the storage device. And that's how you measure latency as perceived by, right? And I want to stress this because a lot of people say, oh, my latency is high. Well, where is your latency high? That matters a heck of a lot because you know what? SQL Server has a perceived latency at the upper layer, right? It runs on top of an operating system that also has a perceived latency as it issues IO against a given device. That IO as issued is, that there's a receiving device that is actually serving that IO. Even that device itself has a perception of what latency is like, right? Because you requested an IO, I replied in this much time, but that's definitely not going to match how much SQL Server thinks that that device actually took. You see how this is a complex discussion? It is a very complex discussion, right? But there is no easy simplification of these things. You do need to understand, though, that latency is actually a series of different pieces of latency throughout a stack. And measuring each and every single one of those is important when you want to fully troubleshoot what happens end to end. So, I'm making it sound super complex. It is, but you know what? The reality is, and most of the time, you don't have to go down that granular of a level. This is why you bring up the professionals, so people that are trained in troubleshooting these issues and help you figure out what's going on. Anyway, store port, how you actually log these things is basically through a single call to logman, which is part of what's called the Windows Performance Analyzer. Okay, you can just go get the Windows Performance Analyzer, and then at that point you'll get logman and you'll get xperf and other things you need to do, among other things, store port trace. Yeah, and store port trace is really utilizing the ETW infrastructure, the event tracing infrastructure that Windows has, which just so happens to be the exact same infrastructure that extended events use underneath the hood in SQL. Okay, because it's very efficient, it's very granular, as close to the code, as close to the real code as possible, with very minimal overhead from the watcher effect, right? So that's important to understand. The store port, problem with store port though, it's very efficient, how it captures information, but it generates a lot of information in the same sense. Because what you do with store port is you say, oh, I want to see what my performance is like against that particular SCSI device that sits on bus number blah, unit number blah, LUN number blah. And that can be a lot of IO, right? Just think about SQL just generating that tiny transaction log record. You think there's just one tiny thing? No, it could be a significant amount of bytes just for that particular tiny little write, right? So it's important to kind of get this in your heads, because these are operations that, even though they seem meager, when you do them by the millions, scalability becomes a problem, right? So anyway, store port, you create your trace, you let it capture, and then you convert your stuff, run this PowerShell script. I'll send you a link to this, don't worry about it. I may not be in the presentation, I'll fix it, it's fine. And then you end up with an analysis Excel like this. And there's even some Power BI stuff and pivot stuff that people have done for this, where filter by port, bus, and target, that kind of thing. You can do really interesting things. But the important part to highlight, what is store port good for? It is good for determining the latency as the I/O leaves your box, leaves Windows, and leaves well, not Linux, it leaves Windows and is issued against that storage device. Windows performed the handoff, right? Windows is in the clear. Now, how long did that storage device actually take to complete that I/O? That is what store port is very good for. Okay, so that's another way of tracing I/O. I've done 2 thus far, right? There's more. So let's go check out another one here for that's based on extended events, and I'm sure that Erin Stellato right now is celebrating this. It's a little extended event session that looks at, and by the way, a lot of our previous speakers have shown extended events. I just want to highlight the fact that extended events can also be used for tracing I/O, because there are several events that may be in the debug channel, like Joey was mentioning earlier, that are not supposed to be used in production unless you're under the ever careful eye of Microsoft's support. Thing is, these are pretty safe to use, but they're going to generate a lot of data, and they can be invasive, and they can affect your performance. So be very careful, please, when you do this stuff. Don't say, oh, Argenis showed me how to debug things with extended events. Let me put this on my instance that's handling 40,000 batches per second. Don't do that. I mean, you guys are smarter than that. So please think about the children. Anyway, what we have here, the extended event session, I already created it here. It's issuing data against the string buffer. So if I go issue I/O against small, right? And right now I'm disconnected, but if I issue that I/O again, am I even on the right database here? Let's switch into TinyDB. The table is not there, it looks like. Okay, so we need to create it. So we create the table, and now we go insert. By the way, yes, I'm on a different VM right now. I was showing things on my computer. Now I'm showing things on my VM, because you know what? I couldn't get to install the Windbg Preview thing from the store into Windows Server 2019. Long conversation, not relevant. What I'm showing you here is that I'm about to do an insert into dbl.small, but I want to trace it with that extended events package. So what I do is show me live data, because it's not running. Okay, we'll kick it off. That's fine. We don't have to stop the session. It's not really that smart about knowing whether the session is running or not, is it? So we kick off the session. Yes, I'm doing things in SSMS. I don't have a script for it. Deal with it. And so I inserted my rows. I'm gonna go watch live data. Insert some more. There we go. So I inserted some stuff, and then things happen. See, so transaction log records being generated. Transaction log flush about to start. A file written. A file write complete. And a transaction log flush complete. So the file write written complete, it's pretty cool, because you actually get a value called duration. And so this duration is actually in nanoseconds, if I'm not mistaken. That's why it's rounded up to 0. But that's ridiculous, right? Or rounded down to 0 in this case. That's pretty ridiculous. There is a way for you to actually peruse the data generated by this extended event session and get some more meaningful numbers about how long it actually took to perform that file write. And so you must be thinking, oh my God, this is awesome. I can tell exactly how much latency was perceived by SQL Server by doing this in extended events session. Didn't I just tell you not to do that? Okay, remember that I just told you to do that, because I told you not to do that. It's an awful idea. If you set this up in a production environment, you're definitely gonna start seeing all sorts of trouble. SQL Server does aggregate these things into what we call VFS, virtual file stats, remember? Yes, that DMV is actually aggregating all of this data constantly. And so that's the perceived latency as seen by SQL Server when I/O is issued for the different files that are involved in your system. It's kind of how it goes. All right, so extended events. That was what is it now? The third way of looking at things? Man, it's just crazy. So now let's look at one more, because we're not done, right? Oh, by the way, store port. If you don't want to use Logman, there is a way for you to create a store port event trace session in perfmod directly by just right-clicking here and saying new data collector set. I've already created one, and the way that it looks like, it's like this. You say provider Windows store port, and then you can define a filter, blah, 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 blah. Not gonna go into that. I'll send you that link that I sent you earlier, which is way easier, and your brain will actually thank you. Okay, so let's go. One more thing, and this is something that I've been doing for years, is showing people how to troubleshoot SQL Server with Sysinternals tools, right? This is Procmon. Procmon does what it says. It monitors processes, but it does so much more than that, right? It actually digs into the different calls that your processes perform, and it tells you exactly how long they took, right? So it's a good thing that we could potentially just say, you know what, let me use this to trace how SQL Server does I/O. So if the process name is SQL servr.exe, then include, and if I hit apply, look at that. I'm only getting I/O from SQL Server over here. Registry accesses and file accesses from SQL Server and nothing else. That's fantastic. So if I say okay, and then I go look at all the stuff that it's filtering out, it's great, right? So now I can go into my insert into small and insert it, and now I go look, and hey, look at that. I got my writes here against the transaction log for TinyDB. Wow, look at that. So write file against TinyDB_log, it was a success, that right, thank the Lord that it was a success. And then it also tells me a few interesting things about that I/O. The number one thing is the offset. What does that actually mean? Within that file itself, I needed to write this much into it, okay? And I also needed to write a given length, meaning I have this much data for you to write. And the I/O flags are also important. It says non-cached. You can't cache this I/O, dude, sorry. Write through, do not leave this I/O on an area of storage that's volatile or ephemeral or non-persistent, because I'm gonna be in trouble. And the priority of the I/O, which should always be normal, please don't go be changing the priority of I/O, because it's bad things are gonna happen, okay? So why is the length 512 bytes though? You have to remember the table was called small for a reason. It's tiny, right? So when it's kind of cute, you want to generate records for it, the records themselves are going to be cute, right? The log records that you're actually going to be landing on that storage device are going to be pretty small. So, and when we get to that, you know, how much do I actually need to write? What is the smallest amount of data that I could possibly write against my storage device so that I can actually do non-cache and write-through operations? That is a disk sector, okay? And that's important to understand, because you're gonna see, depending on the disk sector size of your system, different lengths for transaction log writes that are smaller in size. However, you guys know, if you don't know this already, go watch that previous presentation that I mentioned earlier. SQL Server can actually bundle multiple IOs into what's called in a single log flush, right? It doesn't have to actually do it record by record. It may bundle a bunch of records. It follows a certain logic that's actually documented in that blog post that refers to a blog post from a friend, blah, 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 long story. It's in there. You get the idea of how SQL Server behaves when it's actually doing a lot of transactions, because it doesn't really make sense for SQL Server to go do those many round trips for every single thing that I have to write to the transaction log. Even if you have the fastest storage in the universe, that I/O against that storage device, it's incurring into latency. And latency is exactly what you're trying to minimize. So you bundle more I/O into less I/O requests, and you get better performance, right? So the maximum that SQL Server can do on a transaction log I/O is 60 kilobytes. Somebody explained to me when I was working at Microsoft why it's 60 kilobytes. I already forgot, like, whatever, it's 60 kilobytes. It's not really super important. That's the max that I would actually reach when it's doing I/O against your storage device. By the way, if you're so interested, I can go dig in the archives of why that is. It's not very important in this conversation right now. My point is, I've already shown you one more way of looking at how SQL Server does I/O. We debugged it. We looked at extended events. We looked at store port from the operating system point of view. And we also looked at, by the way, store port, yes, it can be an OS thing. So I'm kind of bundling guest OS tracing and this application tracing kind of thing. And I also show you Procmon, which, showing you how SQL Server is performing I/O, but the application and the operating system issuing I/O themselves are like one thing, right? There's only so many delineations that you can establish between the two, because an operating system cannot do anything without the application or vice versa. Anyway, so where are we at? I think I should just stop this. I should pause. And are there any questions right now, guys? I'm sorry, I've been talking for a long time without stopping for questions.
Nope, just lots of comments about people's brains melting. So I guess you're doing a really good job.
I mean, you guys asked for a level 500 session, so here it is. I was actually like second guessing myself whether this was, and this is your fault, Aaron Stellato. I was second guessing myself on whether this was a level 500. Regardless, this is really what I wanted to convey, right? So we did application tracing in SQL Server. We did a little bit of tracing in the guest as well, right? Through Procmon and through a store port. So now we know that there's quite a few ways of looking at how I/O is performed within the guest OS. Yes, hopefully we're good there. Now, let's talk about the hypervisor, because this is always a great conversation for me. Think about, and I'm not going to talk about Hyper-V in specific because Hyper-V is used, but not as widely used as VMware. And in this case, I'm just going to go with, what the larger segment of the population uses in the world. Here's what happens with the hypervisor. Isn't the hypervisor taking I/O from a truckload of VMs potentially running on top of it? Well, how do you think the hypervisor does that, right? The hypervisor takes incoming I/O from a virtual device as presented to the guest operating system. That on its own is queuing I/O in there, right? It's trying to go all the way through down to a physical device that's connected to your final storage device. Maybe there isn't such device. Maybe you're directly connected to a storage device through a bus in the case of DAS or whatever. Still a lot of things are happening just for I/O to go through, right? So now think back to that one slide that I showed you at the beginning that had that stack for the operating system. There's the stack for the operating system, and here's a completely different stack for the hypervisor itself. Those two go together when you're performing I/O. Exactly. So things get really complex when you're talking about troubleshooting and tracing things of the different layers, even on a hypervisor itself. So I'm gonna make it like real simple for you guys, and I'm gonna really abstract of how things work on VMware. So I'm just going to show you one thing because I also want to leave plenty of time for discussion or maybe for a strong drink after this. One thing that's specifically about VMware, using ESXtop to identify storage performance issues for ESX and ESXi. This article has been around for ages. And the reality is that there isn't a better tool for diagnosing what performance is like within VMware itself. So as you have a guest OS running on top of VMware, you're gonna crank open your trusty SSH session against your ESXi host. Yes, I said SSH session against a vSphere ESXi host. You are gonna do that. Maybe you won't do that, but the guy who's a VMware admin is gonna do that, right? And yes, they are going to have SSH enabled because who doesn't? They're going to run ESXtop, right? That's a tool that allows you to see what's consuming resources within VMware itself. And yes, I know the font is small. My apologies. I don't know how I can make this much better. I can control one with zoom it, I guess, and I can show you that there's a bunch of things running. You probably don't care about this right now. But if you look at all the counters there, they're all like system and wait and idle and ready and things like that. So those are counters that are really important to understand, where's my VM spending time on right now, right? Because you are going to see the different processes for the different VMs running in there, right? This is where things, again, get super ridiculously complex for VMware. You're going to try to understand exactly where your VM is and, what time is spending doing what and that sort of thing. I'm just looking at I/O right now, right? Right now, I don't want to have this conversation about how your VM has less CPU than the other, right? We'll leave that for another day. I just want to know how my I/O is doing. And all you have to do within ESXtop to tell you how your I/O is doing is press the D button. Press the D key. And then at that point, boom, everything changes on ESXtop. And all of a sudden, you start seeing how the virtual HBAs that are connected to your storage array or your storage device are doing. How many reads are they doing? How many commands, SCSI commands are they sending down the path at that time? What the writes per second are, megabytes read per second, megabytes written per second. And then there's the DAVG, KAVG, and GAVG, and QAVG. I never, ever remember what these things mean because number one, my brain refuses to. And number two, I have a great blog post that I can point you to that explains all that stuff, right? So this is the blog post. It was written by my wonderful colleague, Cody Hosterman, who's just a walking encyclopedia of VMware and storage. And he literally tells you exactly all the different concepts that you need to understand when looking at latency metrics on ESX and ESXtop, okay? How much time did it actually take for my IO to be completed after it left the HBA or the host bus adapter through my storage network into my storage device? And how much time did that IO actually spend inside the SXI kernel, and then the aggregate of the two. This stuff is interesting. You're not necessarily tracing IO though. I'm sorry, I want to make that perfectly clear. You're not seeing every IO go through. Right? You're not capturing every IO as being sent down. For that, there's another thing called vSCSI stats that you can use for that purpose. And vSCSI stats is a very specific VMware thing that I'm not going to go into. I'm just going to briefly mention it because otherwise we'll literally be here forever talking about this stuff. Yes, vSCSI stats reminds me a lot of block trace, which is another tool used for tracing IO on Linux subsystems. This is an extremely powerful tool that can actually capture every single IO as sent down. Just, you know, do this reasonably while you use block trace on Linux systems. And yes, you can use it on a hypervisor using QEMU or whatever. As long as it's a Linux box, you can implement block trace. And there are even more efficient ways of tracing IO in Linux these days using the Berkeley packet filter. So if you're a Linux enthusiast, and I'm sure that Nocentino must be going like, oh my God, you mentioned BPF. BPF is kind of like the ETW for Linux. It's super cool infrastructure baked into the Linux kernel that allows for very minimal observer effect or watcher effect overhead on whatever it is that you're looking at. So that's another kind of interesting angle on looking at things, how I can actually capture these IOs as they're performed against my storage device. But you can go crazy with this. Like literally, you can capture every single IO as it's being issued across the across the stack, as long as you're going through that Linux machine, right? We're assuming that a Linux machine is the hypervisor. On VMware, though, going back to what we were talking about on VMware, ESXtop gives you an idea of what the queues look like, and then vSCSI stats helps you not only validate that number, but also capture IOs as they're being issued. So you see how things get crazy, and security teams are like, their ears perk up when they start hearing about these things. That's because if you can capture IO, you can capture data. And you can do with that data whatever you want, can't you? So this is why you're seeing a lot more technologies that encrypt the data on the fly before it even leaves your guest operating system or your container even. These technologies, you're going to see more and more of those because it matters. You're trying to protect the data at every layer. You're trying to provide a comprehensive approach to security. And that means that not even a qualified system administrator will be able to see that data as it leaves your VM or your application even, right? Which is what SQL Server does with Always Encrypted. So that's something important to kind of keep in mind here. All of these things have security implications, big time security implications. Let's see. We talked about ESXtop. We talked about block trace. So we talked about tracing the hypervisor. Are we done with that topic though?
So, hey, Argenis, I do have a few questions here.
Okay, go ahead.
I think they popped up right before you started talking about hypervisor. So
That's okay. No worries. I can go back.
Okay. So how do you see the difference in if the I/O is on NVMe or a slow disk?
So you can easily tell which one is an NVMe device in Windows by looking at the driver that you're using for that particular device. Because right now, Windows doesn't support the other mechanism for placing I/O against NVMe devices, which is across the network, which is called NVMe over Fabrics. Windows doesn't support that yet, right? So we've been pushing the Windows team to support that. Linux has supported it for years now, but Windows hasn't come up with support for it yet. So on Windows, you can directly see if the NVMe driver is being used for a particular device, and hence being able to tell if you're using NVMe or you just have a regular SCSI device. In enterprise servers, it's unlikely that you'll be using anything other than those two, right? Because yes, you could have like IDE, but those are like really ancient technologies. They're not used for enterprises anymore. Good question though. Any other?
Yep. Do you have experience in using dtrace on Windows? Is it just using ETW? Do you see any advantage?
So it depends on what you're trying to troubleshoot. There isn't a silver bullet, right? This is why I didn't make a bunch of slides and show you guys, if you're doing this, use this. If you're doing this, use that. I want you guys to become familiar with the tools. I want you guys to be familiar a little bit with the stack, and then make your own decisions as to who you're going to go talk to if you actually have to troubleshoot this stuff. Because it's unlikely that you're going to be doing it yourselves. And if anything, before you start doing it yourself, you should start familiarizing yourself with how the tools operate, how they work, before, you know, kind of committing crime in production.
That's just crazy talk. I don't know what you're talking about.
Exactly.
I got a couple more here for you. SQL Server recommends disks to be 64K allocation units with 1024 offsets. Is this still the case, or are there new schools of thought on this?
My favorite conversation in the universe, and I'm sure everyone listening to this must be like Argenis. Oh, again, it's going to talk about this. Yes, I am. I was asked a question. So, number one thing they have to remember, and this is again reiterated on those resources that I made available at the beginning, and that talk and that blog post. SQL Server's I/O block size, I/O request size never actually matches the allocation unit size, unless you're bringing a whole extent into the buffer pool. That's the only time when it actually matches 64K. Okay, so 64K is a general recommendation from Microsoft for formatting your NTFS volumes so that you have less allocation units for your database files. And less allocation units means less metadata for the file system. And less metadata for the file system means better performance, as long as that metadata doesn't actually affect allocations, on-the-fly allocations, like PFS, GAM, and SGAM do, right? If you guys watched that session from Pam, when your metadata actually affects that, you may need more metadata, which is the case of PFS, GAM, and SGAM, right? But now they wrote concurrent PFS updates, blah, 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 blah. Long story short, AUs, allocation units, in NTFS are not a metadata, an allocation impacting metadata, meaning a performance impacting metadata, a part of the file system. So my take on it, Microsoft has not come up with newer guidance on NTFS allocation unit sizes. I have, because I think if you have 2019 and later, you should go with the highest available allocation unit size for your database files only, okay? If you have other kinds of files within the file system, you use file stream, file table, or hackathon checkpoint files, meaning in-memory OLTP checkpoint files, stuff like that, they're gonna have a different access pattern than your database files and your transaction log. And in that sense, I don't want to have you guys waste potentially tons of space, disk space, because if you make an AU bigger, then the file every file has to be at the very least that AU, right? So if you have a tiny file that's 2 kilobytes and your allocation unit size is 2 megs, you have effectively how much data that's empty space in your file system, and that's a waste. So do I recommend 2 megabytes? Well, yeah, if you're running a pure storage device, use 2 megabytes because you're running on top of me, I'll support that. If run on top of anyone else, run at 64K, because that's Microsoft recommendation still. So great question, by the way.
Okay. Just a couple more here. It says, didn't see duration in the Procmon for IO. Did they miss it? And when would you recommend using Procmon for troubleshooting?
So that's a great question. I don't think Procmon or maybe does trace the duration. I can't remember exactly. I will point you guys to resources on that later. I believe there's a way to figure that out, but don't quote me on that. Actually, you know what? Let's just look at it. Why not? We're here. You don't have to make you guys wait. So we have that. It's right. It's my Procmon. That's my file, result detail. Select columns. Oh, look at that. Duration. Oh, wow. We got it. Thanks for the question. I have forgotten about that.
Awesome. All right.
Okay. All right. What else do we have?
Let's see. I've got a few more. Do you want to keep going with questions, or do you want to try and finish what you've got?
Let's keep going. People are interested. You know, they're going to fall asleep and their brains are going to turn to mush, and we're not going to be able to make them think anymore. Let's keep going.
All right. Another question. Do you have any experience with the resilient file system in combination with SQL Server?
Oh, yeah. Another religious question. So I have opinions. Use NTFS. Thank you.
Okay. Works for me.
So let me qualify that. REFS is a lot better than it used to be. And by that, I mean a heck of a lot better than it used to be. There are still some questionable things about REFS out there. Tons of things use it. Tons of things in Azure, tons of things on-prem. If you ask me, Argenis works at Pure Storage, just use NTFS, please. I'm not gonna not give you support if you run REFS. How about that? My recommendation, if you're running on top of us, run NTFS. If you're running on top of somebody else, go ask them what they think. This is when it comes down to value. Like, what value are you getting out of REFS? I don't know. Does it give you anything different? You just want to use it because it's nice and fancy and it's got it's not NTFS? I don't know. Like, if you ask me, just run SQL Server on top of NTFS. If you ask me, Microsoft should support NTFS on top of Linux. Why not? Different conversation. Sorry, Angela.
No, that's okay. Let's see. Would you recommend different allocation sizes for log files versus data files?
No, use the recommended for your system, whatever it is.
Okay. ext4 or XFS on Linux?
XFS all the way. ext4 is dead. Argenis said it here.
Okay. Let's see. This one's been in here for a while. It says that they've used Procmon in the past to monitor write durations for the transaction logs. Wait a
second. Sorry, Angela. Before we keep going, I'm going to qualify that.
Okay.
There were still some bugs on XFS that they were figuring out, and by them I mean the Linux vendors were figuring out, and the community were figuring out the bugs in XFS. There may be some extreme situations where ext logs better than XFS for very extreme kind of workloads, right? Don't get hung up on that. Just go with XFS because that's a path forward. That's where the investments are being made right now by the Linux community. So my suggestion is just use XFS. Sorry that I went back. Go ahead.
Nope, that's okay. That's okay. So somebody's just wondering about if there are any downsides to using the Procmon tool.
Of course, you're creating overhead.
Okay.
I mean, listen, every single thing that you put on top of a system can actually derail the performance of that system. And so if you have Procmon running, even though it's built on top of ETW and all that, it's going to affect the performance of your system at scale. And it's actually got memory that backs all the events as they're being captured, and it may start dropping events and stuff like that. So it can be dangerous in prod. Be careful. Everything that I said today can be dangerous in prod, period. Right? I guess next time I do this presentation, I'm going to qualify it by don't do stupid unless you know exactly what you're doing.
Okay. Let's see. Is there any consideration for monitoring hypervisor volumes, but on hyperconverged infrastructure?
Oh, yeah. Another religious discussion. So it depends on what you're talking about. If you're talking about Azure Stack HCI, you're literally running Hyper-V underneath the hood. And then the same concepts that I mentioned for troubleshooting for tracing IO within the guest OS would apply to your Stack HCI. If you're talking about, I don't know, VMware's vSAN and Nutanix and stuff like that, I'm not familiar with all the intricacies of those things. They have to have tools, otherwise their support wouldn't be able to troubleshoot themselves. The question is, can you actually use them and get something meaningful out of them for you as a sysadmin or a database administrator? I don't know.
Okay. And then we've just got a comment from somebody who says that RFS doesn't have the limitation of the sparse files when you grow over 16 gig or so in snapshots. It's the only benefit that they've found. There's
a blog post on purestorage.com that we made a long time ago that actually talks about the large FRS, or the large file record segment. That's another feature of NTFS, another metadata thing for NTFS that you just change, and that way you don't have to deal with that sparse problem that you were dealing with in NTFS before. So yeah, there's an equivalent workaround in NTFS as well. Good point though. REFS does do away with that problem.
Okay. We are at time. We have no more questions. Did you want to continue going?
I don't know. What's the people saying? I can keep going because I think I have very little more to talk about. I have one more demo and then I'm done.
I was gonna say we've got a couple more questions that just popped up. As soon as we tell them that it's done, they ask.
Okay, I'm going to tell you about the demo that I was going to do, and then I'll answer the question, so we'll call it a day, okay?
Okay, perfect.
Because, people in Europe are getting tired, and they want a beer, and I want a beer too, and blah, blah, blah. So the demo that I was going to do is about tracing the storage network. Okay, and the storage network is basically, you have a host, right? Let me actually do this share the screen from my Surface here really quick. So bear with me 1 second. I'm going to share the whiteboard. Okay, here we go. So you have your host here, whatever it is, a VM box or a bare metal box, doesn't matter. And here's your storage device. There is a network in between the two, right? How do I look at things in there? That is the thing that I want you guys to think about, right? There is a network in between my thing that generates IO and my actual storage device, right? So what's the, oh my God, somebody's asking a question about ZFS. Please don't get into that. So, sorry, got distracted by shiny objects. We want to trace the IO as it goes from the host to the storage device. How do we do that? It's a network, right? So in a network, you can sniff the network. So there are multiple ways of doing that. There's port mirroring if you're using a SAN, right, or whatever it is. There is some sort of capability for port mirroring where you can literally see the incoming IO as it's being issued from the host down to the storage array device. Totally can do that, no problem. If you're using iSCSI even, it becomes even easier because you can just use Wireshark, right, to look at the incoming IO on your iSCSI box, which is exactly the demo I was going to show you. However, since we run out of time, we're going to go ahead and I'm going to put that demo on a blog post, or maybe these guys will invite me to talk again here on whatever the name of the next thing is, or what have you. But with that, I'll stop. Let's answer questions, and then we'll go for a beer.
All right, I got one more question for you here. Do you support, and by when they say you, I'm assuming they mean Pure. Do you support installing the SQL engine on any hypervisor instead of a physical machine for hosting half a petabyte sized database?
Why are you asking me Pure specific questions in here? Let's take it offline, please. I don't want to answer Pure specific questions here.
Sure.
Yeah, sorry. I mean, love you guys. Thanks for using my products or looking at them, but I don't want to spend time doing that. Sorry.
Fair enough. Oh, and then somebody was asking if you have the link to the blog post that you were just talking about earlier.
About the large FRS? Yes, yeah. I will make sure that it gets added in here. It's
okay.
If you search blog.purestorage.com large FRS, you'll find it.
Okay. That's it.
Awesome.
Fantastic
Can we drink
stuff,
now?
mate.
So Argenis, I can't type questions in the Q&A panel as a presenter, but can you describe what you just described? But can you talk about that in the context of Linux? Go.
What do you mean in the context of Linux? What are you talking about?
You talked all about Windows, man.
Oh, you just want me to focus on Linux now.
He wants to do the whole presentation again.
Let's do it all again for Linux.
I got a good answer for that, dude. Remember when I said I was going to do VMware over Hyper-V? That's kind of how I feel about Linux. I'm sorry. Everyone uses Windows for SQL Server right now. There's adoption of SQL Server on Linux, but it's not as massive as I guess everyone expected it. Love it. I think if you ask me, I'm a new enterprise. I want to deploy SQL Server for whatever reason. Would I look at Linux over Windows? Probably. Hey, I was the PM for SQL Pal, so I know how it works, and I'm pretty comfortable about it. But I can tell you, the huge majority of the SQL servers that we see out there, out Pure, are all running on Windows. There's a few exceptions to that rule, obviously, but we have significant. If we want to do this session again for Linux, I'm down. So put me down. We'll do it again.
You said earlier that if you were going to be invited back, you will absolutely be invited back. We asked you for a 500 level session. I would have said that was an insanity session. It was absolutely fantastic. Really enjoyed that session.
Appreciate it.